native currency is what? Bitcoin. On Ethereum, what is the native token? It's what? It's Ether. It's Ether. The ETH you are seeing is just a symbol, right? And ETC is also like that, a symbol. Alright. So with Cardano, it was named after who? Ada Lovelace. It was named after Ada Lovelace. He's a programmer for that matter, a mathematician, and he was the first programmer for that matter. And as Mr. Mustafa mentioned, you can break Cardano into what? Smaller units. Just like you can divide dollars into cents. Cardano, you can divide it into what? Lovelace. Right? So when you have one ADA, it means that you have what? 1 million Lovelace. Are we okay? When you have 1 million ADA, you're talking about what? And when you have one ADA, you're talking about what? 1 million Lovelace. Are we okay? Before you can build on Cardano, there are some basic things that you need to understand before you can able to work. Don't be afraid, we're not going to write those here. It's just basic explanation we are going to talk about. And that is what? The blockchain accounting models. Blockchain accounting models. So we have the first one here, UTXO model, which is what? I've attached this point to it, means it is initialized by what? Bitcoin. And then we have the account-based model, which is by Ethereum. Let's move on. So with the account-based model, we are saying that accounts hold balances updated with each transaction, and then similar to what traditional banking. With Ethereum, how the accounting model works is this: when you have money, just like you have money in your mobile money wallets, and then you want to transfer, let's say you have 100 Ghana cedis, you want to transfer 50 Ghana cedis to somebody. Once you transfer, your balance gets updated, right? It gets updated, maybe you with what? 50 cedis. It gets updated. But unlike the UTXO, the Bitcoin model, it deals with the concept of what? Change. Right? It deals with the concept of what? Change. So before you can be able to develop on what? On the Plutus core, you need to start thinking differently from the normal models that exist and the normal smart contracts. The smart contract that exists on Ethereum is different from what exists on Cardano. It's very different. And they are all it's different because of the use of what? The accounting model. So let's dive into the accounting model of the UTXO by Bitcoin. So with the UTXO, we are saying that coins are tracked as unspent transaction outputs. And they are saying that transactions consume UTXOs and create new ones. That is what Bitcoin is doing on the blockchain. In Bitcoin, we are saying that coins are tracked as what? Unspent transaction outputs. That's what the full meaning of what? UTXO, unspent transaction outputs. Right? Do you understand it? Yeah. Unspent transaction outputs. All right. So this one, it deals with the concept of what? Change, as I was saying.
This presentation is it specifically for the developers or for everyone? Because you know, asking us whether we understand.
Oh, sorry. Yeah, for the devs. It's for the devs. It's for the devs. No, but I mean, all of us are potential devs. So
it's important.
Don't worry, you understand that before I finish this. You understand what intellectual is. They will all understand. So please, let's go to the next slide. So this is how the UTXO model is. Now let's think about our normal life here. Let's say you have your 100 Ghana cedis, and then you go to Auntie Amelie decided to go and buy one, let's say a drink, 10 cedis, right?
Yes.
So when you go there, what do? You can't tear your money. There are 100 cedis into pieces and give part to it. That is how you what? You give all the money out. So that is it. So the 100 cedis will be consumed by the woman and then give you what? 2 outputs. The 2 outputs, she is taking what? A share of 10 cedis and then giving you a new balance of what? 90 cedis. Are we okay? Right.
So that is how the UTXO model works. And please, we are, I don't want you to think of it like in a normal terms. We are dealing with technical terms, so maybe you should think technically. So this is an example here. So we are having what? Alice and then what? Bob. So Alice is having 100 ADA, whilst Bob is having 50 ADA. Now we are saying that Alice wants to send 10 ADA to Bob. So she needs to create what? A transaction. She needs to what? Create a transaction. What is a transaction? So a transaction contains three things. They contain arbitrary inputs, output, and then the amount that is going to be sent. So in a transaction, you are going to have what? The inputs. So here, we are seeing what the input to be what? 100 ADA. And then we are seeing Bob to here as what? 50 ADA. So that's the input, right? But here they're saying that Alice wants to send. So they are going to deal with what? Alice inputs. Okay. Now, Alice wants to send what? 10 ADA to what? To Bob. So she needs to what? Create a transaction. So please move on with the next slide. So this is a transaction created. So this transaction is going to consume the whole 100 ADA. Are we okay? It's going to consume the whole 100 ADA. Then it's going to what? Produce 2 outputs, right? Are we okay? So it's going to produce 2 outputs. Please, so these are 2 outputs. So the 2 outputs, this is what? Bob. Bob receiving what? The 10 that is supposed to given to him. Whilst Alice is receiving what? 90 ADA. So now, this one is what? A new UTXO created for what? Alex. So this one is no more. So now this Alice new UTXO created. Right? All right. So now, can we say that based on this, can we say that the output, the sum of the output of what? This. The sum of this output is equal to the inputs of this transaction. Can we say that? Do we agree? Let's think technically. Do we agree? You don't agree? You agree? You agree? I want us to be one here. Do we all agree? Yes, you have a doubt. Please, someone is on the floor. Let me hear you. Exactly. So you see, I said that this presentation we all have to think. So I'm saying that we all have to what? Think technically. So that is why he's saying that he disagrees, and it's true. In fact, it's true. You can't say that this 90 and then 10 will be the same thing, because in normal cryptocurrency, even with your wallet you created, if you have 10 ADA and you have to transfer, you can't transfer all the 10 ADA. Some parts has to be consumed by gas fees, right? So you are not going to receive what? The same. So this is just a presentation I'm trying to tell you here. So you're not going to receive the same thing here. Now let's look at another logic, a very complex one. Now you see that Alice is having what? 90 ADA, Bob is having 10 and 50 ADA here. So suppose that they are to transfer another, let's say Bob is transferring 55 ADA, whilst Alice is transferring another 55 ADA to someone. What will happen? Suppose, they have already given you a clue already. All right, so this is what will happen. Who can explain this to me? So they are sending what? 55 ADA to what? To Charlie. So this is Alice. Alice has no choice. He has only one what? UTXO. So the transaction will consume everything, right? The same way with Bob. Bob 50 ADA is not up to 55 ADA, right? The same way 10 is not up. So Bob has to consume, he has to combine all the unspent transaction output, the UTXO, combine them, and then it will be consumed by the what? The transaction. Once it's consumed, it's going to what? Give an output of what? 110 ADA to what? Charlie, because Alice is bringing what? 55, and then Bob is bringing 55, making it 110. Then Bob receiving a balance of what? 5 ADA. And then Alice still receiving a balance of what? 35 ADA. Are we okay? Are we okay? Oh, this is simple. Hello? It's not simple. You said? So someone is asking, where is the output of who? Charlie. So this is Charlie's first output. This is his new UTXO created. This guy who Bob, yeah, initially he had only one. And then they Alice sent 10 ADA to him, making him having what? 2 UTXO. And he didn't consume any of it. So since you want to spend, and then his balances, the 2 balances, and one is not up, he has to combine everything, right? Because he's going to send 55, and 50 is not up to that, 10 is not up. So when you combine the 55, 50 plus 10, you're going to have 60. So with that, he can combine and then consume and spend that money. Are we okay?
So if you want to spend 60,
I don't get your question, please. Oh, you feel free to ask your question. So
somewhere as one out, like this one. Meanwhile, Alice sent him 55.
once it's signed, it goes out, the public key. Once you use your private key to sign a transaction, it goes out to what? To the public key, so that the devs on the blockchain can verify the transaction to make sure that it's true that Alice, this money belongs to you, so you can what? Spend it. All right. So you have to understand that you can't just spend money like that. Before you spend money on the blockchain, you have to what? Verify your output. Right. So in Bitcoin, it is only one output, only one verification that you can use, using what? Your private keys. All right. So now let's go to the extended UTXO. So this is what Cardano introduces. So I hope you understand the concept of UTXO. So with the UTXO, it's based on what? Bitcoin. So now Cardano uses what? Extended UTXO. Right? They have added some significant changes to the what? UTXO model, and they are using it as their what? Their main development tool. All right. So with the UTXO, we are saying that it combines UTXO security and what parallelism with what? Account-based flexibility. So the account-based model, I hope we all know them, the Ethereum and then what? The Bitcoin. So Cardano combines this, but actually they are in the middle of it. You'll get to understand all this. Transactions are deterministic and what? Predictable. And then it enhances smart contract security and efficiency. So I have a next slide to explain all this point for us to understand. So let's take the Alice example again, right? So now this is Alice, and then which is 100 ADA, and now you want to what? Spend, right? So let's go again. Exactly. So here in Cardano, they introduce what we call a redeemer. A redeemer, datum, and then scripts. These are the very important things you need to understand. Very important when you are to develop on the Cardano blockchain. So we have what? The redeemer, the scripts, and then what? The datum. Now, what is the redeemer? The redeemer. It's just like, the redeemer is just like an answer to what? To the datum. What? The data. So let's understand this one perfectly, and then the scripts, I will try to break it down for you. So with the first one, we have the scripts. All the blockchains, the Bitcoin, the Ethereum, and then Cardano, they all come with what? Different scripts. So with Bitcoin, in fact, they come with smart contracts, but they are saying that it's not smart enough. So they call it what? The Bitcoin script. So with the Bitcoin script, what it sees is that before a transaction can take place, it will see what? The redeemer. The redeemer contains some codes, right? Some logic, digital logic. So instead of them using only digital signature, hello? Instead of using only digital signature, right? You are going to what? Include something like redeemer. Are you okay? Redeemer. So in Bitcoin, they only see what? The redeemer. Whilst in Ethereum is having a very powerful script, the Solidity script, right? It's very powerful. Their smart contract, it can see the whole blockchain. It can see the input, the outputs, whatever is happening on the blockchain, right? And the Ethereum and the Cardano blockchain, that's what I'm saying, that it's in the middle, the Cardano blockchain, right? It can't see the whole blockchain, but it can what? See the redeemer, the input, the output, and the processes. So this is how it works. Like the 100 ADA from Alice, Cardano has what? Added what we call datum. That is where the smart contract runs inside. So with the datum, it's a piece of code that will be describing or some instructions given to what? To the 100 ADA, right? That's maybe if this happens, this one should go through. Are you okay? And here is what we have, the what? The redeemer. The redeemer is like you having the answer to what? To the contract set by what? The datum. Are you okay? So with the redeemer, it's going to what? Answer the what? The instructions set by what? The datum. So that instruction must be satisfied before you can spend the 100 ADA. Are you okay? Hello? So with the redeemer, it has to answer the question set by what? The datum, right? Before we can what? Be able to spend the data. And then we have the scripts. The scripts, they call it validator script. And that script is the one going to what? Check the datum and then what? The redeemer. And see whether the redeemer really satisfy the what? The requirements of the datum. Are you okay? Right? All right. So we should understand all this. So that is what goes through. So once this script gets satisfied, and this one I'm talking about, we are not talking about your normal sending of euro, like you have your normal money from euro and then you are sending. We are talking about actual deployments on smart contracts, right? Yeah. So this is what has to go through. So with this, it has made the Cardano smart contract as powerful as what? As the Ethereum script, right? So this is the same way that is going to what? Happen on the transaction. So this is the transaction, then the output, that is going to, just that with the normal UTXO, you'll see that they are only going to sign with the public key and their private keys. But with here, you are going to have some set of instructions attached to the 100 data you are sending, right? Sometimes it could be metadata, right? Then you're going to send them. Please, let's move on to the next slide. All right. So now, let's talk about the more important things. The smart contracts on what? Cardano. So we are saying that a smart contract is a self-executing piece of code that automatically enforces an agreement once predefined conditions are met. Right? This English, right? So with those who have small coding experience with, let's say, Python or Java or JavaScript, you see we have something like conditional statements, like the if else statement. So you can think of the smart contract as such statement, right? So what the condition states is that if you set a condition that Mr. Osman, if Mr. Osman is a boy, give him water to drink, right? So that's the code you have set there. And then, so once you run a program, it will come and check, Mr. Osman, whether are you really a boy? Then, if you confirm that you're a boy, then the program what? It gives the what? The money or the water to the what? To the person without anyone interfering. No one can interfere, right? Once you set the contract, it is running. No one. Once the conditions are met, it's going to execute. So it's smart because it eliminates the need for what? A trusted intermediary by running on the blockchain, where every step is transparent, tamper-proof, and what? Irreversible. So that's the power of what? The smart contracts on the Cardano. Please, let me see the next slide. All right. So how do we develop this smart contract on Cardano? Trust me, it's very hard. Yeah. But it's hard, but it is doable, right? It's possible. Yeah. It's possible because the approach Cardano uses is very different because of the functional programming they use, which is Haskell, right? So before you can be able to build, you need to understand Haskell, what Haskell is about. You need to be able to learn the basics and then the in and out of Haskell language. It's a programming language. Then after learning Haskell, then you now deal with what? Plutus, right? Plutus is built, it's like a framework, which is built on what? On Haskell for allowing what? Smart contracts. Mostly you write Plutus code when you want to run the code and your program on chain, on the blockchain. But mostly if you are doing the off-chain stuff, you can decide to use Haskell. But on the main net of Cardano, you have to what? Use the Plutus language. And then we have what? Malloy. It's a what? A domain-specific language for financial contracts. Right? You have to also understand the what? The Malloy. Right? It's a DSL. It's a DSL for what? Financial contracts. So what is a financial contract? Financial contracts. Okay. Any other input? Yes, sir. Exactly. All right. So it could be anything. When you go and then borrow loan, when you borrow money from Quick Loan, whatever, you sign a contract with them, right? So those are the financial contracts, right? So you are going to use the Malloy to what? To develop those contracts. And they made it so easy. They understand that it's not everybody, and that's why there are spaces for everybody. With the Plutus core, you have to be a developer. You need to be a developer before you can use it. But with the Malloy, you don't have to necessarily be a developer. If you have financial background, right, you can be able to what? It's like a template you are going to use, right? With financial background, you can be able to what? Set these conditions. And then those with the knowledge of what Plutus will what? Will do the coding, right? So they use Plutus to actually develop the financial contracts. Are we okay? But it's a set rules. You have to plan the contracts there. Then use your Plutus to what? Execute the codes. Are we okay? All right. So this one we talk about them. So that's the Plutus. It's Cardano's primary language and framework for writing smart contracts. It is based on the Haskell programming language, which is known for a strong emphasis on safety and correctness. All right. So please, you move on. And then we have also talked about the Malloy. It's a domain-specific language. And then the on-chain and then off-chain scripts. I think I mentioned this, right? About the off-chain. Who can remember what I said? The off-chain. So to get started with developing on Cardano, several tools and resources are available. In fact, this is we have the Plutus Playground. It's an online environment to write and test Plutus smart contracts without running a full Cardano node, right? But it's unfortunate, as I told you, the tooling of Cardano is still evolving. So the Plutus Playground is currently not effective. I mean, they use the playground that was for the Pioneer program that was somewhere 3 years ago or stuff. So currently it's not being maintained, right? But there are other things. This one, you write it online. It's a Plutus online, but you can install it locally. All right. And then we have the Malloy program too, is the Cardano developer portal. But aside this, I told you that before you learn Plutus, you need to understand what Haskell is all about, right? So where do you learn Haskell? So you see, there are online there are some online resources available, right, where you can get Haskell, like they'll break it down to you for you to understand what Haskell is all about, and some examples. You can go to tutorialspoint.com, right? We all know tutorials point. If you're a programmer, you definitely know what is it. So when you go to tutorials point, you can look for a language called what? Haskell. If you have a phone, you can go on it and search this right now, so that you'll not forget. I didn't add that one to the slides. So I said, well, you can go to tutorials point, right? Then you look for Haskell, right? And now, how do you run your Haskell codes? You have to what? Be able to test your code, whether it's working or not. Now you have two options. We have an online editor and compiler, which will help you run your code online. So it means you're going to need a lot of data, a good internet connectivity for running your code online. Or otherwise, you can install it locally on your device using Next, right? So you can install it locally using Next, and you install GHC on your device so that if you have VS Code, it's perfect. You run them in your command line, right? You use the command line to install Next and everything so that you can execute and compile your code using the VS Code. Or you can use online editor called Replete. That's the name, Replete. Yeah. So you can go to Replete too. And Replete is very great for the online, right? Replete is very good. It has now they have added AI to them, so that if you see a code and you don't understand, just put it inside Replete and tell you that you should explain this code to you, right? It will break it down for you to understand what it actually is. Now there are a lot of resources available for you to learn easily, right? So we should take advantage of this online system. So I said that you can use tutorials points, right? Has someone seen it? Who's having it? Let me show it to them. All right. So we have tutorials point here. Okay. So please, you can go to tutorials points, and you can get all right, and you can get some Haskell course. It's very free. It's free. When you just go there, you don't even need to sign up. You can just read through, and then you can use Replete as your online editor. For that, you have to sign up so that you can get access to this AI models to be able to run your code. Okay, and then there will be resources available. There are resources available on the Cardano developer portal, where you are going to go through how to start and do everything, building smart contracts. All right. You are going back home. Okay. I'll get started with the Cardano development. Okay, you go. All right, so there are some things you need to also get familiar with. We have the Daedalus. It's a Cardano wallet. Just that one is different from the Yoroi, right? That one it's used for actual development, right? It can host the whole blockchain, and you can have it on your as a extension on Chrome, right? And then we have the Yoroi. It's a lightweight wallet that connects to trusted servers, offering a quicker setup. We also have different ones. We have the